to the channel. So in this video I'll be telling you about XML retrieval. So this is also one of the most important concept when it comes to information retrieval. So what does XML stands for? So XML stands for Extensible Markup Language. So we are going to deal with what do you mean by XML retrieval. Now coming for the introduction, let us revisit what is IR and what are relational database. So IR is nothing but information retrieval, means we are going to fetch the information from any given unknown document. And here when we are taking the example of relational database, it is going to be the structural format, means it is going to contain the form of tuples and attributes. So IR systems are often contrasted with relational database, means IR systems are totally opposite to relational databases. That is why IR systems retrieve information from unstructured text. Now, relational database are used for querying only relational data, but IR systems are more uh, useful for unstructured data, not for structured data. Now, some structured data sources contain text are best modeled as structured documents rather than the relational data. Then what is XML retrieval? Whether XML retrieval will come under structured or semi-structured or unstructured retrieval or what? So XML retrieval is going to be the structured retrieval. So yeah, as you are able to see in the screen, the structured retrieval. So the structured retrieval queries are structured or unstructured, but documents will be structured. Queries are structured or unstructured, we don't know, which is given by the user. But documents are going to remain structured. Now, what are the applications of structured retrieval? Now, patent libraries, digital libraries, blogs, tag text like persons and locations, etc. So these are the best examples of structured retrieval. Then why RDB, that is relational databases, are not suitable in this case? Since IR systems are going to deal majorly with unstructured data, if we use IR systems only for structured data, then our application might fail in many of the circumstances, because we might not be able to fetch the documents from unstructured data. Means in today's world, most of the data which is present are unstructured. So when we are retrieving or fetching any data, the IR system should be able to fetch the relevant data even from the unstructured documents also. As I have already seen in the previous page that queries are going to be structured or unstructured, but documents will be always be structured when it comes for structured retrieval. So IR system building only for this doesn't make any sense. So an unranked system would return potentially large number of articles that mention the Vatican, Colosseum, sightseeing tours without ranking them by relevance to query. Suppose a query is given, and if an unranked system, if it returns large number of documents to a given query without even ranking them, there might be a sort of redundancy and everything. So that is one of the issue. Another one is we should not build only with respect to structured. If our IR system is working only for structured, then our application will fail in many of the circumstances. In a simple note, if we want to understand. Now, difficult for users to precisely state structural constraints. So sometimes users might face difficulty while giving the constraints such that I need to retrieve only that part itself. When it comes for structured data, that is your RDB, relational databases. But that is not the case when it comes to unstructured. It is a very convenient for users to give the constraints. Now, users may be completely unfamiliar with structured search and advanced search interfaces. Yes, users might not be familiar with the structured search. They might they have become habituated only with respect to unstructured. That is why. So what is the solution for this? Now adapt ranked retrieval to structured documents to address these problems. So this is the solution which we can address to overcome these three problems. Now coming for the comparison between RDB search, unstructured retrieval, and structured retrieval. Now, in RDB search, objects are records. Unstructured retrieval, unstructured documents. Now, structured retrieval trees with text that lays. Now, we will be able to see XML retrieval is an example of structured retrieval. Then, how does XML retrieval is going to look? Let us go. I'm going to tell you in the upcoming parts. Now, Main data structure which is used. RDB search, it is table. Unstructured retrieval, inverted index. Structured retrieval, there is question mark. Model. In RDB search, we are going to use relational model. In unstructured retrieval, we will be using vector space and others. In structured retrieval, we don't know. So for this, to fill these gaps which are present in structured retrieval, we will be using XML Retrieval. So XML stands for Extensible Markup Language, as I have told at the start of the video. It is also applicable to other types of markup. It is almost similar to your HTML. I hope everyone will be knowing HTML, Hypertext Markup Language. So for that, XML is almost same like that only. So we call XML retrieval as the structured retrieval, but few researchers, they prefer the term semi-structured retrieval to distinguish XML retrieval from the database querying. Now this is how your XML document is going to look. So here you're able to see play, author, Shakespeare and all those things. So if you are looking at this document, this play, author, title, act, these are all will be the nodes. So an element can have one or more XML attributes. So XML document is basically an ordered labeled tree document. Now each node of the tree in the XML document written with an opening and the closing XML tag. The attribute can have child elements also, like for example title, verse, example like this. As you are able to see, act number, scene, stage, verse. So these are all childs of title, like that. Now, as I told, XML is going to be the structured. It is going to look like this, the XML document. So root element play. Under play, we are having author, act, title. Under author, text, Shakespeare, act, element, scene, title, and which act or which drama we are checking, Macbeth. Now scene attribute number equal to 1. Now attribute, if attribute number equal to 7, in from scene it transforms to stage. Then from stage, which verse. So under which verse, which text it is. Will I with wine. Text is Macbeth's castle. So like this means in a structured format, in a proper format, I'll be mentioning the contents in the XML document. Now leaf nodes consist of text. For example, this is the text. In XML document, remember one thing, leaf nodes are going to be text. Here I have already shown here and it is highlighted also. Now internal nodes encode document structure or metadata functions. For example, element author, element tag, element title, element scene, element stage, element verse, like that. So these internal nodes encode the document structure or the metadata function. Now XML basics. Separate layout from presentation. That is your syntax from versus semantics. Now XML document object model. Even in as how HTML has its own DOM, even XML is also having its own DOM. So DOM, as simple, if you want to tell, it is document object model. So it represents elements, attributes and text within elements as a nodes in a tree. So as you're able to see, elements, attributes, texts, everything, it is represented in the form of a tree. Now with the DOM API, we can process an XML documents by starting at the root element and then descending down the tree from parents to the children. So we can process the XML document from the root, as you have seen. From here we can process it and we can go towards the root element. Now XPath, standard for enumerating path in an XML document collection. Now schema is nothing but the structure of the XML document. Simple, if I want to tell, it is structure of the XML document. Now if you want to put constraints, you can put constraints on the structure of XML document. Example, scheme of a Shakespeare's plays are scenes as occur as children of acts. Now a query, which while we are writing a query for XML document, so the standard format which is followed is NEXI format. So NEXI stands for Narrow NEXI Extended XPath 1. So this is the format of your NEXI format. So this is how the XML document looks like. Article section. From article we will get section. From section we are having two parts. One is summer, another one is holidays. So this is your NEXI format. which I'm showing. So slash slash article bracket square brackets open dot slash slash yr equal to 2001 or dot slash slash yr equal to 2002. Now section about opening brackets dot comma summer holidays. So this is how your Nexi format is going to look for a given XML document. Now tree representation of XML documents and queries. So this is your XML document, and for this it is the XML format, the tree representation of XML document format. Now what are the challenges what when we are evaluating the XML documents? When we are dealing with the XML documents, what are the challenges we face? Now, the first challenge is document paths to retrieve. So, structured or XML retrieval. So, user want to return parts of documents, not entire documents as IR systems, as we usually do in the unstructured retrieval. Now, if we query Shakespeare's plays for Macbeth's Castle, should we return the scene, the act, or the entire play? So, in this case, the user is probably looking for the scene. However, an otherwise unspecified search for Macbeth should return the play of this name, but not a subunit. So user wants us to return only parts of documents, but not entire documents. Now solution structured document retrieval principle. Now what does this structured document retrieval principle stands for? One criterion for selecting the most appropriate part of a document. System should always retrieve most specific part of a document answering the query. Means whatever the IR system you build, that IR system should be able to retrieve the most specific part of a document which is relevant to the given query. Now, it motivates a retrieval strategy that returns the smallest unit that contains the information sought but does not go below this level. But it is very hard to implement this principle algorithmically. Now, for example, query title. Now, usually the user will be expecting for the scene. Okay, so if I have built an IR system, that IR system should understand the user's query, and from the XML document which is present, it should be able to return or retrieve only the scene part for the user. Now, Macbeth can match both the title of the tragedy, Macbeth, and title of Act 1, Scene 7, Macbeth's Castle. Means Macbeth word can have many hits, but in this case, the title of the tragedy higher note is preferred. Difficult to decide which level of the tree satisfies the query. Means basically when we are having more amount of redundancy or more amount of repetitive word in the given document, and when the user gives query just as a single word, it becomes very difficult which part to be taken to retrieve and return to the user. Now that was the first challenge. Coming for the second challenge, document paths to index. So consider any documents in a unstructured retrieval. We will like examples are your email messages, web pages, images, audio clips, video clips, everything. Now when you come for structured retrieval, we'll be having four paths. One is your non-overlapping pseudo documents, and another one is top down, third one is bottom up, fourth one is all. Now coming for your approach one, that is your non-overlapping pseudo documents. Pseudo means nil. Simple. Pseudo means it's null. Now group nodes into non-overlapping pseudo documents. Now indexing units are book, chapter, section, but without overlap. Book, chapter, section. There is no overlap at all. Now disadvantage. Pseudo documents may not make sense to the user. Pseudo means basically null. There is no sense at all. So if you are non-overlapping pseudo documents, then it is of no use. Now, XML indexing unit approach to. Now coming for your top-down process, that is your two-stage process. Start with one of the latest element as the indexing unit and post-process search results to find for each book the sub-element that is best hit. Means start from the top node and go till the end of the node. Means from root to leaf. This two-stage retrieval process often fails to return the best sub-element because relevance of whole book is often not a good predictor. Now coming for your bottom up. Bottom up means start from the leaf node, group, uh, evaluate and group the elements and go towards the root node. That is your indexing unit approach 3. Now coming for all, index all elements. That is your least restrictive approach. Also problematic. The XML elements are not meaningful search results. Now indexing all elements for the search results might be redundant. Now when we have nested elements, returning redundant nested elements is not user friendly. Now what is the third challenge which is associated? Now, nested elements. Now, because of the redundancy which is caused by nested element, it is common to restrict the set of elements which are eligible for the retrieval. Now, restriction strategies could include discard all small elements which are present in the XML document. Now, discard all element types that users do not look at, means for which users are not interested to look for. Discard all those documents from the discard all those elements from the document, and discard all element types that assessors generally do not judge to be relevant. Only keep element types that a system designer or librarian has deemed to be useful for search results. Now remove nested elements in a post-processing step to reduce redundancy. Now collapse several nested elements in the results list and use only highlighting of query terms to draw the user's attention to the relevant passage. Means what is required for the user, mention only that, and remaining whatever the nested element, nested paths, what are there, remove all those things. Now, nested elements and term statistics. Now, further challenge related to the nesting. We may need to distinguish different contexts of a term when we compute term statistics for ranking, in particular, inverse document frequency. Of course, when we are removing the nested elements, we can't say whether all nested elements are irrelevant or not. So, it is better to give the ranking first, means giving your inverse document frequency. Now we may need to distinguish also different contexts of term when we compute term statistics. Solution for this problem is compute idea for XML context terms. For example, they have given an example here. The term gates under the node author is unrelated to an occurrence under context node like section if used to refer to the plural of gate. Now, it makes little sense to compute a single document frequency for gates in this example. Now, sparse data problems, that is, many XML context pairs occur too rarely to reliably estimate DF. Now, what is the compromise? Now, consider the parent node X of the term and not the rest of the path from root to X distinguished context. So with this note, I will be ending the video. In the next video, I will cover from vector space model. So keep sharing the videos. Thank you.